over the surface of the moon, even closer than the space station flies above the Earth. And that those flybys have given us really some intimate details on the surfaces of and the conditions of the Saturnian moons. One thing the Saturnian moons, most of them have in common, is craters. Okay, impact scars, and you only have to look at a moon like Rhea, which is about half the size of our moon, or the Death Star moon Mimas, which is about 3.5 times smaller than Rhea, to see that there was a time long ago when there were lots of bodies careening around the solar system with enormous amounts of energy and smashing headlong into the planets and into the satellites as they were forming. And these collisions did a great deal to sculpt the solar system and make it look like it does today. They were responsible, first of all, for allowing the planets to grow to their present size. They were responsible, a collision with a Mars-sized object was responsible for tilting Uranus on its side. A collision with a Mars-sized object was probably responsible for creating our moon by carving out the outer part of the Earth, throwing it into orbit, from which later on the moon coalesced and became a body. They smashed up small satellites. The impactor that created this crater on Mimas came very close to smashing it to bits, so it doesn't take a rocket scientist to figure out there must have been some collisions which did, in fact, break up small moons, and in fact, that's one of our thoughts for how planetary rings come about. And then, of course, don't forget that, and some of these collisions probably created the irregular bodies we see in the Saturn system. There's Epimetheus, about 100 kilometers across. There's Pandora. I showed you Pandora before, again about 100 kilometers across, looking a lot smoother than Epimetheus, but nonetheless cratered. And then here is Hyperion, about 200 kilometers across, looking like something Marcia pulled out of the ocean. Okay, so lots of cratered objects everywhere. And then also don't forget, we think it was a collision with a comet that wiped out the dinosaurs, which cleared the way for the eventual development and successful evolution of primates, of which we like to think were the culmination. So collisions are an important planetary process, and we can learn a lot by studying the effects that they have on bodies. One of the things we do with the craters is look at the density of craters across the surface of a body, because that's the way we work out the chronology of what's happened to this moon. If the moon is cratered in places but not in others, we say that the place where it's not cratered is a young surface. It has been reworked. It's the reason why the moon is cratered and the Earth is not. The Earth's surface has been reworked through, in our case, through plate tectonics. So that's the way we come to understand the geological history, and we're doing that quite a lot in studying the Saturnian moons. This is the moon Iapetus, okay, known ever since it was discovered